All right. Hi everyone. How are you guys doing? So we had a little bit of a break in between. I hope you guys enjoyed the Git sessions. So we're back and we're live on day 11 of the Frontend Bootcamp. And today we'll be learning about prototype and a few of the modern JavaScript concepts. And good evening to all of you in the chat. Um, So, did you guys find the hackathon? Did you participate in it? Were you able to complete the challenges? You can let me know in the chat. All right. So, in the last session, we were looking at how we can create objects, and we were, um looking into what a prototype is, what a prototype chain is. But then, YouTube did not allow us to proceed. We kind of broke off uh, YouTube, and you know we were not able to proceed with the lesson. So let's continue where we had kind of left off. So we were looking at different ways by which we can create an object. So the first one was the object literal syntax, wherein you can just use make use of these curly brackets, and with in between the curly brackets you specify the property and its value, the key value pair, right? Then the other way was that we could make use of the object, uh, and then add properties to it like this. Then the third way was that we create a function constructor, and we created two objects. One was Jane and the other one was Gaurav. We added the first name and the last name, and then when we looked at both of these objects, they had a prototype associated with them. So let me open this in the live server. Okay, yeah. And you can see that the first person is let me zoom this for you guys. Okay, yeah. So when we look at this log statement, hang on a second, sorry about that. Okay, so when we look at the contents of this log statement, it is showing us that the this is a type of person. The object is a person type, and then what we wanted to do is we wanted to so originally this person object, or the person prototype, it does not have this print name functionality. And using the special object known as prototype, we added this print name functionality, which return the combination of first name plus last name, right? So afterwards we were able to do Jane.print name, and we got the first name and last name returned by this function, right? So the prototype is a special object. It uh, you know it itself has its own prototype. So if we look at this object and we look at this prototype property, this is an object on its own. When we expand this, this is coming from the main object. And then if we look at this one, it doesn't have any prototype further, right? So what this indicates to us is that everything in JavaScript is an object. The prototype for every object is this object. This is what every other object is created out of. Then the other thing is, I mean, we get certain properties and functions which are available. So for example, we were looking at this particular call, right? So we do not have any function defined on this person known as, toString, right? So we are still able to do something like Gaurav dot first name dot toString. So how is it able to, access this function? It is able to access this function because first what it does is it will look for this function within, this object. So if we examine this object, right, it doesn't have any toString function. Then what we will do is, yeah, the JavaScript runtime, what it will do is it will check in the prototype object, is there any toString function available over here? So we can see that, oh, even over here there isn't a toString function. Then it looks at the next object in the prototype chain, right? So here you can see there is a toString and there is some implementation for it. So this is known as the prototype chain. So whenever you try to access any, property or method on an object, right, it will first look within the, within the object itself. If it doesn't find it over there, it will look at the next, uh, you know uh, the prototype chain, right? So it will look in the prototype and then it will look in its own, prototype, like that. So this prototype within prototype, and this goes on until we reach this, object, basically this object type of, you can see that the constructor for this particular one is person, then for the constructor for this is the object itself, right? So by unless and until we reach the end of the chain, which is mostly the object prototype, right, uh, it will keep on looking for a property or a function, and if it doesn't find it, it will probably return undefined and we will get an exception, right? So this is what the prototype chain is. And the next example that we were looking at is, you know, suppose we look at this array, right? Rather, let me create an empty array like this. If we expand this, even this has a prototype, right? Which is the array prototype itself. So all of the data types which are available in JavaScript, they have a prototype associated with them. So for example, if we create an empty object, right, it's this object which is the prototype for this. If we look at the array itself, it has all the functions, defined over here. Some of them we had looked at, for example, slice, right? Slice function, push, pop. These are some of the functions we have looked at so far. And if we look at the prototype for this, you can see that this is the object itself. And this is where the chain will end, right? Suppose what I want to do is, I have this array with me. So for example, let first set equals 1, 3, 5, 8, 10, like this. And then let's create another set. This is a set of numbers, for example. So let's add some more numbers over here: 2, 6, 9, and 12, and 45, 30, 27, something like this. And let's log both of these in the console. First set and second, sorry, not second set, another set, like this. And we can see both of these values available over here, right? Now suppose what I want to do is, for all the arrays which are available, I want to add a new functionality which gives me just all of the even numbers that are there in an array. Okay, so what I can do is, I can, as we know that the prototype for this an array is the array itself, right? So we access the array prototype, then we say array dot prototype, then we create a new function, even numbers, for example. Okay, and we say that this we give it a function. Okay, and what that function will do is you'll just say return this dot filter. Filter is another functionality which is available on the array, right? So if we look at over here, we have a function known as filter. What this does is that it goes through all of the elements in the array one by one, and we specify a condition. If that condition is true, it filters out, the rest of the items which do not satisfy that condition. Okay, so what we will do over here is you'll say item, right? And so this basically accepts a callback function. So let's give it a callback function, and what we will do is you'll say return item, and we will check if, an item represents an individual number, right? So it will go through each of these items in an array one by one, and it will check whether um, the remainder for that, when we try to divide the number by 2, whether the remainder is 0 or not. This is the condition that we will be used to filter out the even numbers. Okay, so we have, extended the array prototype and added a new function known as even numbers. So initially, if we try to do something like first set dot before, so if we do something like first set dot even numbers, since we have added this to the prototype, right, you can see that it's giving us that of the first set of numbers, 8 and 10 are the only even ones. All right, and similarly, if we do another set dot even numbers and we execute this function, it is giving us all the even numbers that were present in this array, right? So the advantage of using a prototype is that, you can extend a prototype at any given point of time, and you do it at the level of the prototype, and that functionality or that property, it becomes available to all the objects which are based on that prototype. So we know that both of these variables, or both of these arrays, are based on the array prototype, and now at any given point of time we can, basically add a new functionality, and it will be available on all the objects which are based on the array prototype. Okay, then another benefit is that, we can basically extend any existing functionality, right? So we can even, suppose I have, what I want to do is, I want to change the way the filter functionality works. For example, I want to add some more things to it. Maybe I want to add a log statement along with the filter functionality, right? So what I can do is I can give it the function like this, and what I can say is, so suppose, let me take a reference. Okay, let original filter equals array dot prototype dot filter, like this. So we have taken the reference of the original filter function, and then suppose what I want to do is return. So we have this dot, or rather we can say original filter, and then we want to call this with all of the items, right? So we will say items, and then what we want to do over here is console.log each item. So, and we will basically just return this function like this. Okay, and suppose I do the same thing, another set dot, filter, and what I want to do is, so I will specify over here this dot items, rather, hang on a sec. What I want to do is, I have the original filter, and to that let me original filter dot call, and I want to give it the reference of this, and what we want to do is, so actually we'll come back to this point a bit later on. As far as extending an existing functionality, let's leave it for now. We'll come back to this a bit later on. But what I wanted to tell you guys is that we can, suppose we have an existing filter functionality and we want to change its behavior. We want to do maybe something like, we just want to log the values in the console, right? So what I can do is, I can say array dot prototype dot filter equals, console dot log. Okay, and whatever is the value that we are passing, it will log it over there. For example, I just give it the reference of console.log. This is how you can even break an existing functionality. So it is dangerous to kind of overwrite the existing function which is available on a prototype, right? So suppose I do something like first set dot filter now, okay, and I call this, it's giving me undefined because I've kind of broken off the functionality for this. So suppose if I just say one, for example, is just logging that because we have replaced that with console.log function. So if we want, we can extend the functionality in a way, but we have to be careful as to what we are doing with existing functions which are available already, right? So we can change the behavior of an existing functionality as well. So we just have to be careful with how we do it. So these are some of the benefits of doing things on the prototype. Another thing is, as we see that we make a change on the prototype and we added the even numbers function, right? So it was directly made available to both of these objects. Now another thing is, what we need to understand is the concept known as call by value and call by reference. Okay, so we have something known as call by value, which basically means that, you know suppose we have a variable like a. Okay, a equals 2, then I say let b equals a, right? And then I say, so let me do a console, or rather let me show this example to you guys over here, right here in the developer tool. So we have something like this. We have a which is equal to 2, then we are saying b which is equal to a basically. So a and b both are equal to 2. Now suppose what I do is I reassign a to 4, right? And now if we look at the values for b, b still, it's still equal to 2. So all the primitive data types, right, like for example numbers, strings, booleans, all of these, the primitive data types, they are, their values are, passed by, value, each variable holds a copy of that value, right? So when I say that, b is equal to a, right? What that basically means is that the value which is assigned to A will be copied to, the variable B, right? So it holds a copy of, whatever was the value assigned to this variable. Okay. And that is why when we are modifying A to 4, since B was holding a copy of that, right, not exactly the same value, even though we modified A, B was still, B was still equal to 2. Now there's something different when we use user defined data types such as objects, right? So what happens in that case is, suppose I have, so A and B points to different memory locations, right? If I have something like this, okay, so I have A equals 2, and then B equals A, right? So in memory, okay, this is some memory location. So when I'm saying A equals 2, this is pointing to a separate, memory location, and B is also pointing to another memory location. So this is a, memory, right, location, which holds this value. Similarly, when I'm saying B equals A, it is creating a copy of this and placing that value in a, new memory location, right? So B is pointing to this new memory location. Now when I say uh, A is equal to 4, basically what it is doing is it is updating this value over here, right? So that is why there is no impact on the value which is assigned to B. Okay. But in case of objects, so suppose I have an object like this. Now I say A equals, first name. Okay. First name is, oh yeah, I need to assign a value. So suppose John, for example. Okay. And then I say B is equal to A, right? So you can see that even B is, having the same object. And then now if I do something like this, B dot, or rather if I do A dot first name equals, Jane. Now if I do B dot first name, even that has been modified, right? So the difference is that whenever we use an object, these values are assigned by reference, right? So in memory, it is like this now. Let me just copy this. Okay. So now when we are saying something like, first name, and so that information is basically available over here, right? First name, whatever, for example, John. Okay. And then when we are saying B is equal to A, so both of them are pointing to the same memory location. Okay. So even B is pointing to this memory location and A is also pointing to the same location. So both of them are having reference to the same memory location. This is how JavaScript works. In case of objects, a reference is always assigned to the variable, right? So A is also pointing to the same memory location, and when I say B is equal to A, it's pointing to the same memory location. When we modify something over here, right, when I'm saying A dot first name is equal to Jane, so the contents of this memory location or the value at this memory location would be changed. Now since both of them are pointing to the same memory location, When I say b dot first name, even it's getting the same value basically, right? So this is known as, pass by reference, and this is known as pass by value. And similarly, we have a concept like this for functions as well, like call by value and call by ref. Uh, so so what happens is, the advantage of having a prototype is that these are all objects, right? All of these prototypes are objects. So whenever we create a new instance of this array, some memory space is taken up, right? So since we are using making changes to the prototype, all of the objects which are of this type will automatically have access to all of the functionality. And since this is a reference, right, a new copy is not created. It's not like we are creating new copies every time an object is instantiated. Whenever a new object is created, so for example, over here, whenever we're creating a new person, the print name functionality is available on the prototype, right? And the prototype is available as a reference within both of these objects. These functions are not duplicated, right? So because of that, whenever we are creating a new person object, it's only taking up memory for these variables. It's not taking up space for this one, right? It's not creating a new copy of the print name function within this uh, person object, right? So another advantage of having a prototype model is that, instead of having copies, we are having references, which is saving up this amount of memory that that particular object takes up, right? So that is the benefit of this. Then let us look at a couple of other ways by which we can create an object. So the next type is, we had looked at everything till the function constructor. There's another method known as Object.create, right? And what happens is, this function creates a it accepts an object as a parameter, and it uses that as the prototype to create a new object, right? And a new object is created. So for example, we have this object let org. Okay, we are creating an organization. For example, the value for org is devs nest, right? And then let's create another object, say you know employee, or rather person, another person, for example. And what we will do now is, we will say object dot create. So what we're trying to do is, we are trying to create for example, a new employee joins Devsnest, for example, or somebody new joins Devsnest. So what we want is, all of the uh, people who are joining Devsnest, they should have the org property set as Devsnest, right? Because they're joining this organization. So I will say object.create, and I'll pass the object which I want to use as the prototype, right? And what I want to say is, it should have there should be a name property available, right? And the value for that is, say, you know foo, right? And let's log this in the console, another person. Okay, we have already used this variable, so let me just say new person, like this. Okay, new person has already been declared. Okay, yeah, we had created. So let me just rename it once again, new person for org, like this. Let me just do a refresh. Um, what is the error? Let me comment this out. New person for org has already been declared at line 57. Yeah, okay. Yeah, so what seems to be the problem? This is funny. So let me just do this instead. I don't know, for some reason I'm not able to create this variable. It's giving me some error. All right. So let me just save this. So you can see that we created a new object using Object.create. We said that this will be the prototype for the new object that we are creating, and the new object that we are trying to create will have a new property known as name. So if we look at this in the log, we can just see that the name property has been set to foo, right? And if we expand this and we take a look at the prototype, we can see that on the prototype the org has been set to Devsnest, right? So using Object.create, we are able to create objects, right? And create a new object for which, we can use another object as the prototype, right? So this is something known as, pure prototypical inheritance. So this can be achieved using the Object.create functionality, right? Similarly, suppose what we do is, let me try if I'm able to take this in a variable now. So some person equals Object.create, like this, and let's see if the log statement works now. Yeah, you can see that it's working now. I don't know, for some reason it wasn't working earlier. um, and then what I do is, suppose at the org level I add a new location. So org.location, for example, is New Delhi, right? Then let's just log this some person once again. You can see that I modified the location and the organization, and you can see that the location property is available as well within the prototype for this uh, this particular object. Then similarly, we have some built-in functions available on the object, right? Which is this particular object, right? So we have Object.hasOwn, and we pass the name of the object and the property that we want to check. So this function basically allows us to check whether a property which is defined on an object is its own or it's coming from the prototype. So for example, let me uh, specify name over here. Okay, let me copy this. We'll just check this directly in the console. So you can see that it is printing true, right? Because the name property has been defined on some person, it is giving us true. Now suppose I give a property known as location, you can see that it's giving us false. Okay, we can do some person dot location, we are getting the value, but when I do object dot has own, since location has been defined on the prototype, it's not its own property, right? So there is this functionality known as hasOwn. You can make use of this to figure out whether a particular property belongs to that object or it's coming from its prototype, right? Um, so the reason why I'm explaining you this is because we have the next object creation method known as object dot assign. This is a function. It allows us to merge multiple objects together. So for example, uh, we have, let some person equals name, for example Gaurav, and then let car equals some car. Okay, and then if I make use of object dot assign, and if I specify the object to which I want to assign the properties of these two objects, so it kind of allows me to merge the properties of multiple objects. So I specify the object over here, the first object, then the second object, like this. And let's log this to the console. Okay, and we have given an empty object over here, right? So whatever are the properties available on these two objects, it will create a it will merge all of those and create a new object and assign those properties to this empty object. Okay, so you can see that uh, the name and the car properties have been merged together, and they have been assigned to this object, and that is what we are logging in the console. So this function allows us to merge multiple objects together. So for example, but there's a but, right? It does not consider the properties coming from the prototype. So whatever is defined on the prototype, that it will skip. Okay, so it only so for whatever properties for which we have this has own result as true, right? Only those properties will be merged and a new object would be created, right? So for example, uh, you know this person Fu becomes a millionaire and decides to quit Devsnest and buy a new BMW, for example. So we can represent this, right? So Fu is no longer an employee, right? So we will say object dot assign. We will have a new object, then we will specify that you know some person, which is the object which we had created using object.create, and we had used the org as the prototype, and we want to merge it with another object. So Fu bought a BMW, right? So if we look at this, okay, you can see that some person, if you look at the car for this some person, okay, the car is available, but all of the information which was available on the prototype, for example the name of the organization and the location, all of that information has it's not there anymore, right? So let me just comment this out for a second. Some b is not defined, and we had some person over here. Let me change this to, for example, first name. Okay, Okay, and then we have this some person available over here. It should have merged both of these objects together. So there is this car property known as BMW. Okay, let me just take this variable over here and let's just say the car is BMW. And if I specify car P like this, okay. So basically what you can see is actually the result that we were expecting is that the first name property should have come over here. But for some reason, I'm not very sure about it right now. What is the reason behind this? Let me get back to you guys on this. We'll look at this a bit later, but the idea is that whenever we make use of object.assign, you see that over here when we examine the prototype for this, we have the organization available to us. When we look at the prototype over here, it does not have the organization property which is available, right? So all of the things which are coming from the prototype, they are ignored by this object.assign functionality basically. Okay, so only properties which are defined on an object, those are available. Why it is not getting the first name for the and assigning that over here, I'll get back to you guys with regards to that. And the other way by which you can create a new object is the class way, right? So what you can do is you can say class shape, for example, and then we have a constructor over here, and then it accepts a height, and a width, and then we can say this dot height equals height, and then we can say this dot width equals width, like this. And then we can create a new instance of the shape. So for example, let rectangle equals new shape. Okay, and then we give it a height and width of say 10 and 20. Let's log this to the console, rectangle. So you can see that it has created a new object. Its prototype is shape, right? You can see over here, instead of the word function, we have shape over here. Sorry, we are having the keyword as class, right? So this is the difference between a function constructor and a class based constructor. Then for example, let's create a we want to create a another shape known as say square, for example, and it extends the shape, right? And then we will just say constructor, it accepts a dimension, and then we just call the base class for this, which would be shape itself, and we specify both of them as dimension comma dimension, like this. And then when we say console.log new square, right? So you can see that so what I need to say over here is new square of say 10, for example. So you can see that the height and width, both of them have been set to 10, right? So this is how you can create a prototype using the using the class way of creating an object, right? So you can create you can create objects using a class or a function constructor or the object literal syntax. The most preferable one is the object literal syntax because of uh, you know the amount of code that we write, right? When you're defining a class, you're creating a constructor, you're writing all of these keywords, even when you're using a function constructor. So this is a much simpler way. So this is the preferred way of creating an object in JavaScript. So we have looked at the different ways by which you can create an object, and we also looked at the prototypical inheritance. We also looked at pass by value and pass by reference. So for all the primitive data types, numbers, booleans, strings, all of those are all primitive data types. So the values are, you know they are copies basically whenever they're assigned to a variable. And in terms of objects, a reference is always passed, right? So that is what I had explained to you guys over here. Then we'll get back to how Object.assign really works. And I we also looked at how Object.create works, right? um, it allow it we specify a prototype object over here, and new objects are created based on that prototype. Okay, then let's look at the uh, so prototype is not a method of the object, it is a property basically. And that property holds reference to whatever is the prototype for that object. So if we look at this square over here, this is a special property, right? And this holds the reference to whatever is the prototype for the square. So the prototype for the square is shape, right? Then the prototype for the shape is the object class itself, right? And then when we expand the object class, we no longer have the prototype property available. So this is the end of the prototype chain for us. So for example, we have this shape, right? So we can create a method on this class known as area, for example, and then we can just say return this dot height into this dot width. Okay, and when we examine this, you can see that there is no function available at the level of the at this level. When we look at its prototype, you can find that there's an area function available. Okay, and now when I do something like new square dot area like this, we can see that it's giving us the area as 100, right, for this square, because 10 times 10 is 100, right? And if we were to do area for this rectangle, it would give us the value as 200. Okay, so this is how you can access methods which are defined on the prototype chain. So this is basically syntactic sugar on top of all the things that we had learned so far. So over here we were manually adding or defining properties on the prototype like this person dot prototype dot print name, something like this, right? When we use a class based way, either we have the function available, we can directly define the function over here, or if later on we decide to extend the class like this, so we can just say shape dot prototype dot whatever new functionality that we want to add. So that functionality will be available to all the objects for for which shape is the prototype, right? Yeah, it can be a prototype. Every function which is available, that this is a function, right? But in terms of terminology, in terms of a class, this is known as a method and this is known as a property. Okay, when we are talking about classes and objects, right? This is known as a method, and then this is sorry, yeah, this is known as a method and this is known as a property, just to get the terminology correct. Okay, all right. So these are all the things that I wanted to cover with regards to object creation and the prototype, the prototypical inheritance. The next topic is we have a special object known as window, right? And you guys might be wondering, there's another object known as the document. What is like the difference between the two? So to understand the difference between the two, let's do one thing. Let's go to our portfolio. Let me open it over here. Let me minimize this for a bit. All right, so this was the portfolio that we have created so far. And so you can see that we have this scroll available over here, right? And so you can think of the window as the visible, part, uh, the part of the screen that you're seeing, that is, what the window sort of represents. And the document is, the length of the document over here is much greater than the window, right? That is why we have this scroll. So within a window, only a particular, part of the document is visible, right? At any given point of time, if the document is too big, the window only shows us, the visible portion of the document. As we are scrolling, we're moving to, another part of the document, but the window is just showing us a certain, part of the document. So the window sort of, it's basically the browser, but when we talk about, window in general, window, it just represents the part which is visible to you. And the document can be thought of as the, the entire, page over here, right? So this entire thing is the document, and the window kind of just represents the area which is, the part of the document which is visible to us. Now, there are certain, special properties available on the window. So for example, let me just comment out this part. So that no, we are no longer seeing these phrases. So we were talking about, the scrolling part. So there is, this special property known as scroll y. It tells us how much we have scrolled within the window. Okay, so right now I haven't scrolled at all, right? So it's giving us the value as 0. Now suppose I scroll, to somewhere around here. If I examine the value for scroll y now, it's 613. What this indicates is that we have moved around 613 pixels from the top. So initially it was 0. Now as we are going down, we have moved somewhere around 613 pixels from the top, right? So suppose what we want to do is, initially we want the header to remain in place only when we have crossed, this part, this intro part, right? That is when the header becomes sticky. So let's take a look at how we can, achieve some of these things using the window object. Another thing is, the window also has a, every element has this property known as, offset height. So for example, not the window, rather, for example, we have this body, right? Window dot document dot body dot offset height. So we can see that the total height for this, this entire document is 2583 pixels. if we just look at the window dot client, or rather window dot inner height, right? It's telling us that the height of the window is just 286 pixels, because I have this, these developer tools, scroll all the way up. Now if I do window dot inner height, since more space is available, the height of the window is 496. So what this basically means is that our document's height is 2583, okay, and only 496 pixels out of 2583 would be visible at a time of this document, because that is the height of this document. So we have different properties available on the window, like inner height. It is also available on an element, right? So for example, let me inspect this. uh, so if you see this represents this article, right? This intro tag. And what we want to do is we want to access this right here. So there's a very good shortcut available in Chrome. So if you just do $0, so whatever was the highlighted element in the elements tab, you can access it using $0. So it's telling us that $0, basically this is the element which we had highlighted, right? Over here, this article tag. If I highlight this element and now if I say $0, it's giving me a reference to this. So instead of doing document dot get element by id or document dot query selector, getting the element by uh, using any of those DOM methods, just in the console, this feature is only available in the developer tools. You can just say $0, it will point to whatever is the currently selected element. So even for this particular element, $0 dot inner height. So inner height is not available, since that is only available on a window. We have something known as the offset height, right? So this tells us the height which this element is taking up in this, right, within this document. So it is 641 pixels, right? So suppose what we want to do is, by the time we have scrolled beyond this section, this intro section, till that time the header should remain over here. Once we cross this part, that is when it should become sticky. So let's see how we can achieve that. So what we will do is, we'll go to the styling for this. We'll look for the header class. We can see that the position has been set to sticky. Let's change it to static, for example. So now you can see that the header is staying where it is, as long as we are scrolling. Okay, and what we want to do now is, when we have scrolled past the intro section, okay, we want the header to become sticky. So the way we can achieve this is, what we can do is, you can say window dot add event listener. We are interested in when the window is being scrolled, right? So the scroll event is available to us. We'll specify a function over here which will get called every time a scroll happens, right? And then what we want to do is, we want to access this element. We want to see what is its height, right? So you will say let intro equals document dot query selector, and we have given it the intro class, right? So we get access to this particular element, right? And just like we have a height for the element, we also have something known as the offset top. So if I just do $0 dot offset top over here, it's giving me the value as 62. So what does this mean? It means that this element is it starts from 62 pixels from the top, right? Because we have the header, it is taking up some space. If we inspect this, you can see the dimensions of this header are 61 and a half. So it's kind of giving us a rounded off value, right? So after 62 pixels, this particular element is rendered, right? So the offset top property kind of tells us that after how many, after how much distance from the top has this element been rendered, right? So we are getting this value as 62. So what we want to do is we want to calculate, this area, right? We want to know whether we have crossed this area or not. So to get the total distance, right, from this till here, we know that dollar zero, which is basically this element, dot offset height gives us the height for this element, right? So you can see that it's 641.25 over here, right? This is giving us the height. Okay, the height taken up by this element. To get the entire distance, we will say offset height plus offset top, like this, and we're getting the total distance as 703. So once we have gone beyond 703, we want this header to become sticky once again. So as we are scrolling, we want to check if window dot scroll y, it tells us how much we have scrolled from the top, whether this distance is greater than or equal to intro, right? Intro dot offset height plus intro dot offset top. Okay, this will give us that total distance, right? Whether the whether we have scrolled past this distance or not. Okay, this value of scroll y should be greater than this. If this condition is true, what we will do is, let me just put this in brackets, okay, so that this operation happens first and then this condition is evaluated. Then we will say we want to access the header, right? So we will say this dot document dot query selector, we want to access the header, so the class for the header is dot header, like this. So we want to modify its style and we want to set the position property to sticky whenever this condition is true, right? And if this condition is false, we will just say that we want the position to be set as revert, whatever was the original value for the position property on this element, right, on the header, we wanted to revert back to that, right? Okay, so now we have implemented this. As we are scrolling, right, let me add a console.log window dot scroll y. Okay, so as we are scrolling, we are seeing the y position. The moment we go beyond 703, you can see that the header becomes sticky, right? So once again, we start seeing the header and it sticks to the top like this. Okay. So this is how you can make use of the window object, and you can access the dimensions of the window and you can write all sorts of logic over here. um, we can make use of this same functionality to achieve something like an infinite scroll, right? So you guys can look further into all of these different properties which are available on an element. So there's a property known as client height as well. uh, so client height considers the height of the content part of the element. When we look at offset height, It includes everything, including the vertical padding, the borders, and the content, right? So the sum of all of that is known as the offset height. Okay. And the term offset basically represents, the height of the uh, um, you know of this element, relative to its, parent, right? So for example, the offset top for a absolutely positioned element would be different. So if its parent element, for example, we have two elements, right? uh, so right now, this particular, this element, this article element, right? it its, parent is basically this body tag, right? So the offset top has been calculated with respect to, that element. Suppose this article tag, suppose, this main tag had its position as relative. Okay. So let me just set the position to relative over here, and this article tag, let me change its position to absolute, for example, right? Okay. And now if we try to get the let me change the top, for example, I will move this down by say 10 pixels. Okay. This main container, I will move this down by 10 pixels. And now if I try to, access the offset top for that element, earlier it was 62, right? Now if I access the offset top for this element, you can see that it is 0. The reason why it is 0 is because with regards to this main tag, right, it is appearing right where, it's beginning right where the main tag is, right? So within the main tag, its offset top is 0 because it's beginning right here where the main tag begins, right? Earlier it was the body element, so the body would begin over here and the intro section would begin over here. So there was a distance of 62 pixels. Right now we have set, the position for main as relative, and you have set the position for this as absolute, so it is being positioned with respect to this main element, right? So that is why its offset top is now 0. So you have to be careful while using these properties. You should have an understanding of where the element is present, who is its parent, and based on that you will be getting the values. So there are more of such properties available. They have been shared in the resources given along with the assignment, so you can go through those. Okay. And let's do one thing. Let's take a break now, and then we look at some of the modern JavaScript features which have been available to us in the recent years. In the meantime, if you guys have any questions with regards to whatever we have learned so far, you can ask me. So there are no questions. You guys can ask me in the chat if there are any questions. Um, window is the viewport. You can think of, getting the dimensions for the viewport using the window, sort of. So if you're changing the dimensions, you're not specifying a hard coded value for the pixels, right? We over here we wrote everything with respect to, whatever is the current value for scroll, whatever is the offset height for the intro, offset top for the intro, right? So all of these things would change if we're using a responsive design, and we are not using any fixed values. Whatever, the dimensions which would be taken up by the element in that responsive design or on a different device, we would be getting those values over here, right? So the issue that you're talking about, if we measure everything in pixels, so those pixel values would change based on the device, correct? So we would not be getting the issue that you're talking about. And so were you guys able to go through the hackathon? How many of you were able to complete the hackathon, figure out how to align the apply the different stylings for creating the text editor, making text bold or underlined, and creating a new note? Okay, so a few of you are saying that you were able to complete it. uh, Bold and underline problem. You could have made use of the font style property, or you could have set the font weight. uh, okay, but were you guys able to do the part which was related to creating a new note and persisting the previous notes information? All right, so that's nice. You guys were able to do copy, bold and underline, and even selection. Okay, so it's okay if you were not able to submit it on time, but I hope you were able to complete the project. And in case you were not able to complete it, do look at how other people have done the project. Definitely try to figure out what is the solution. How to work parallelly in team. So I guess in the previous two sessions you guys learned about Git, right? So you can take up one particular piece of functionality, you can create a branch out of that, right? And another person can work on another branch, and then when both of you guys are done, you can merge both of the branches together. It takes some level of understanding to work with all of different people, and um, you guys, with with time, you know it shouldn't you should be able to work together. But like, if you're trying to, you have two options. You can, if you're trying to work together, either you can do something known as pair programming, where both of you are working together, screen is shared. You can do something like that, or like I mentioned, divide the functionality into parts, create a separate branch out of it. You work on your functionality and the other person works on that functionality. When it is done, you try to integrate both of the functionalities together. um, any web resource that teaches UI design, I think Smashing Magazine is a good uh, place where you can go through their articles. I'll just type the name of the magazine in the chat. Okay. And similarly, there are a few websites such as you know dribble which give you where people basically showcase some designs. So you have some ideas available with you, and there are some courses available definitely, which where using which you can enhance your knowledge of UX basically. um, and even to pick color palettes, there are different websites. So there is color hunt, there is this website colors.co. You can pick different themes, different color combinations. So these are some of the examples which you can go through, right? And yeah, I mean, it takes a bit of a getting used to going through all of these examples and improving your skills while creating a design, right? It comes with practice, but these are some of the resources which you can use as reference. Okay. So let's look at the rest of the topics which are related to modern JavaScript. Let's go back to our instance of VS Code which we had opened earlier. Let me create a new file over here, modern JS. Uh, okay, let me link it over here. All right, let's comment this out. New features in JavaScript. All right, so in the recent years we have different versions of JavaScript coming up every year. So there's something known as ECMAScript, right? You guys might have read this term somewhere, ECMAScript. uh, ECMA script like this, or maybe you have read something like ES6. So all of these are standardized versions of JavaScript. So there's a committee which is responsible for standardizing the behavior of JavaScript across different browsers. So so suppose I am on this ES6 version of ECMAScript or JavaScript, and so earlier what used to happen is different browsers used to have different implementations of JavaScript. So that is why a standardization was required, so that when I say I am on ES6, or the ECMAScript 6 version of JavaScript, that standardized version of JavaScript. Okay, when a browser says I am on ES6, so all of the functionality which is ES6 of one browser will match all of the functionality of ES6 of another browser. Okay, before the standardization, this was not the case. Some browsers had some functionality of JavaScript, another browser had another functionality. To standardize all of that, we have this you know ECMAScript available to us. Up till 2015 we had something known as ES5. So far whatever I have taught to you guys, most of the features that we were learning, they were related to ECMAScript. Okay, ECMAScript 5. Then around 2015 a new version of ECMAScript came along known as ES6, which introduced a quite a lot of new features in JavaScript. uh, so either you might be seeing something like ES6 or ES 2015. So when you go to the internet and search for latest ECMAScript version, you might get something like ES 2022, which is the latest version of ECMAScript for this particular year, and new features are added to the language every year. So let's look at a few of them. The first one is the template literal syntax, right? So what this deals with is so earlier we were using something known as string concatenation, right? So suppose I wanted to do something like this. I have this variable const name equals John. Okay, const age equals for example 28. Okay, so I want to do something like this console.log. I want to combine I want to use these values in a statement. So I will do something like, hi, my name is plus name, and my age is plus age, like this. Okay, so you can see that it's saying, hi, my name is John and my age is 28, like this, for example. Now using the template literal syntax, what we can do is we can replace these double quotes with this backtick. Okay, this backtick is available generally below the escape key. It's like on the number, all the where all the numbers are, just before that, generally that is where you should find this key. Okay, and I end my string with a backtick as well. Now when we are using this syntax of writing a string, what we can do is, instead of saying, using string concatenation, we can directly access the value of a variable using this dollar and dollar sign and opening and closing parentheses. Whatever we specify within this dollar and this, that particular variable is accessible to us. Okay, and similarly my age is, so I can say dollar age, like this. So we're getting the same output as before, right? And this is much easier to read, right? So suppose I change, the I rename this variable to, for example, first name, like this. Okay, so you can see that the template literal syntax allows me to combine a string, and we can have any set of JavaScript, any piece of JavaScript statement or expression over here. We can have any JavaScript expression over here. So for example, uh, and uh, I want to say that I want to print whether and my age is greater, so is so based on some condition, I can have a condition over here as well. If age is greater than 30, I can say that age is greater than 30 question mark. I can make use of the ternary operator, and I can say greater than 30. Otherwise I can say less than 30. Okay, so hi, my name is John and my age is less than 30. So I can have any sort of expression over here as well. So this is the advantage of using the template literal syntax. You can combine expressions and strings and all of that within a single line, and you can have formatting also done very easily. For example, I want to wrap this particular name in double quotes, so you can see that we can do it very easily. Whereas if I wanted to do the same thing over here, I would have to escape that character, right? So I would have to do something like, you know, backslash something like this to achieve the same functionality. So you can see that now I have access to double quote over here. So we would have to do all of this kind of things before ES6 came along. So these are some of the advantages of using these template literal syntax. Then the next thing that is available to us is known as the shorthand property, right? So the shorthand property, what this allows us to do is, suppose I want to create an object. So let person equals, I want to have properties such as first name, and I am assigning it the value coming from this variable first name. And similarly, I want to have another property such as age, which is getting its value from this variable, right? And let's log this to the console. So you can see that we have created an object with these properties and the values are coming from these two variables. Now, instead of writing, you can see that the name of the variable and the name of this property is the same, right? So instead of writing that property twice, what we can do is we can just get rid of this, the property definition part. We can just specify the variables over here. Since the name of the variables and the name of the properties are going to be same, we can omit the key, the key over here. And if I save this over here, we can see that a new object has been created with the same properties, right? So this is known as the shorthand property, using which you don't need to explicitly specify key and value pairs. You just provide the variable over here, and it will use the name of that variable as the key while creating the object. Suppose I change this to just a, right? So you can see that now we have the property, the key for this property as a and its value as John. Okay, so this is known as the shorthand property. Similarly, like suppose we wanted to add this print me function like this. Okay, and this basically logs this dot first name and this dot age to the console. Okay, so we can see that we have this print me function like this. Instead, suppose we have you know a function available to us outside print me. We can just, so we have let print me equals something like this, and over here we just say print me. So the same functionality is available. Another thing that we can do is, instead of specifying a property value, we can just directly create a function over here on the spot like this, and you can say this dot first name, uh no console dot log this dot first name comma this dot age like this. So even this works. Okay, it indirectly creates a key with this particular name. All right, so all of this is possible thanks to the shorthand property syntax. Now the next feature that we are interested in is known as destructuring. Okay, what this allows us to do is, let's create an object. Let another person. Okay, and we have first name, for example foo, last name bar, and then we have an address, which is an object in turn, which has a city, for example p, let me just say Pune for example, and the state is MH Maharashtra like this. And what I want to do is, I am just interested in the first name of this object, right? So let's log the another person object in the console, so you can see that it is printing first name, last name, and the address. Now, if I was just interested in, the first name of this person, what I can do is I can destructure this particular object. The syntax for that is I'm just interested in the first name, right? So I specify the name of the property that I'm interested in. And since we want to destructure an object, right? The property that we are interested in, we specify that within curly brackets. And the object from which we want to extract this property, we specify that object over here like this. And then we can say something like, I think we have this variable available to us over here, right? So let me just comment this out for now. Okay. And let's save this. Cannot access first name. Let's see. Line number. Right. So all of these examples were using that. So I'll just comment this out for now. Okay. So you can see that we extracted just the first name property. So what it did is that uh, it looked for this key in this object, and whatever was the value, right, of the first name, it assigned that value to this variable. So it created a new variable known as first name, right? And it looked for this key within this object, another person. So it searched for first name, it found the value as foo, and whatever was the value of foo, it assigned to this variable first name. And that is what we have logged to the console. So you can see that it's printing the first name. Similarly, if I'm interested in the last name, so I can destructure that as well, and let's log that to the console as well. So you can see foo bar, right? Now we can also destructure nested objects. So instead of just the first name and the last name, I'm just interested in this city that the person lives in. So this object, this city is a property of the address, right? So first I need to specify address, and then within that I destructure it further. I just pick up the city which is available in this address, and now let's log the city, right? So you can see that it's logging foo as well as the city. So you can destructure nested objects as well. Okay, if I try to log address over here, we'll get an error. Okay, because address, it did not destructure address and create a variable out of it, because we are just interested in the city, right? So it just destructured the city property and it created a variable out of that only. So address is not available. Suppose we're interested in address as well, the entire address object. So we can specify it like this. Okay. And now when I have saved this, you can see that we have foo, then the value for city, and then the entire address object over here, right? So that is how you can destructure nested objects as well, right? Just like how we can destructure objects, we can also destructure arrays. Okay. So suppose I have an array of fruits. Okay. So I have apple, kiwi, and orange, right? And what I want to do is generally to access the first, you know, uh, item of an array, I would say, suppose I want to access apple, right? I want to print that value to the console. What I can do is first, sorry, not first, fruits at the 0th index, right? So we will get the first element in the fruits array, right? Suppose I wanted to do the same thing using destructuring. So what I can do is I can say const Since we're destructuring an array, we use the square brackets. I give some random variable name. I can call it as ABC, but let's just give it the name as apple. Okay, that is equal to fruits. Okay, and let's log this in the console coming from the destructuring of array. And actually you can make use of the template literal syntax over here, and we'll just say dollar apple like this. So you can see coming from, you know, destructured array, and we're getting the value as apple. Okay, now suppose I want to get the value for kiwi as well. So suppose I give that variable name as k, so I can get that value over here as well. It's dollar k like this. So now it's printing apple as well as kiwi. So over here what is important is the order in which the variables are, you know, defined. So we have two variables over here, right? So this particular variable will have the value at index 0, this one at index 1, and if we add another variable over here, it will have that value in that variable, you know. So this is how you can destructure arrays. Similarly, suppose you're just interested in, you know, the first, or rather you're just interested in getting the last, you know, value of an array. So we have three items over here, right? We're not interested in the first one, so we just specify a comma. We're not interested in the second one, so we leave that one as blank as well, and then we're just interested in the third one, right? So let's create a variable by the name of orange, and let's log that value over here. Okay, so now we're getting coming from destructured array, and the value is orange. So we skipped, you know, the first and the second items from the array like this. So you just specify to skip the, you know, items in an array. You can just leave that as blank and put a comma over there. Okay, uh, so the order in which, you know, you're how you're specifying these, you know, variables over here, that is you know, important. Whatever is the first, suppose I specify a over here, b over here like this. So a will always point to apple, and suppose I switch this, right? I say orange over here, and then I say a over here, right? Now, even though I'm logging the value as orange, right? Since orange is appearing at the first position, it is pointing to the first item in the array, right? So the position is important over here. The variable name is not important. You can give any variable name. The position of where that variable is, you know, the property that you're trying to destructure is appearing in over here, that is important. Okay, similarly, we have something known as an alias in destructuring. So suppose I want to call this first name as just name. Okay, while destructuring it, what I can do is I can access the first name property, call it as name, right? And I'm getting this from another person, so let's just log this to the console, alias as name, and we will just print the value name over here. You can see aliased as name, you know, we are calling first name as name now, so I can call it as, you know, for example, given name, right, like this. So I am giving another name to the property which I have just destructured. So you give the name of the property colon and the, you know, renaming of that property over here. So this is something that you can do while destructuring. Okay, then similarly, we have something known as the rest operator. It is denoted by these three dots or the ellipsis notation. Okay, ellipsis notation. Okay, these three dots are known as ellipses. All right. um, so what I want to do is suppose I have let's create a variable const, first name. Let's give it an alias, say, name, like this. And the rest of the properties I want to have access to them in this variable. I'll call that variable as remaining, right? And that is equal to another person. Okay, so only the first name property would be destructured and the remaining properties would be added to a new object known as remaining. Okay, let's log this in the console and you can see the difference. Name and remaining, like this. Okay, so we can see that name was printed, right, foo. And then when I made use of the rest operator, which is these three dots, whatever were the remaining properties which were not destructured, which were available on this object, they were all moved to this new object, and they are available over here. So last name and address, that is something which we were not destructuring, right? So all of those remaining properties were copied into this new object remaining. So you can give any variable name over here. I can also call this as rest, for example. Okay, and we're getting the same result as before. So this is some variable name. And if you want to move the remaining properties into a new object, you can make use of the rest operator. So this is how you can use the rest operator for an object. Similarly, you can do that for an array as well. So we have const apple. We are getting apple in one variable and the remaining in another, right? So we'll assign this to fruits and we'll just log the values over here, apple, right, and remaining. Okay, so you can see that apple was logged individually, and the remaining items of the array were moved into a new array, this variable, and it created a new array out of the remaining items of the existing array, right? So kiwi and orange were moved into a new array, and you can see that a new array is logged over here. So this is how you can destructure an array, and you can get the remaining values in a new object known as the using the rest operator. Similarly, we have something known as the spread operator. So for example, I want to create a new array known as more fruits, for example. Okay, so using the spread operator, I can get the individual values, which is basically fruits. So if we look at more fruits over here, we have spread across all of the fruits which are available. So now we're just getting apple, kiwi, and orange. So if I were to not write it like this, I would get an array of arrays, right? When I look at more fruits, so it is an array of arrays, right? So you can see that at the 0th index, we have, you know, the fruits array. This is known as array of arrays, right? But we want to spread all the values which were available in fruits. So that is why when we look at more fruits, now it's the same thing as before. And let's create, for example, another list of fruits, for example. And I want to add strawberry and pineapple to it. Okay, and then I want to, combine both of these arrays into this more fruits, right? So I can spread the fruits array as well as spread the another, list of fruits, right? And if we log this in the console, like this, you can see that both of these arrays have been merged and a new array is available to us, right? Apple, kiwi, orange, strawberry, and pineapple, right? So this is how you can spread the values of an array. Similarly, we can also spread the values of an object. So let's just say console.log, you know, another person, like this. So you can see we have first name, last name, something like this. Uh, Suppose we want to create a new object which consists of another person. So we are spreading all of the values which are available in another person, and we want to add a new property, say country, for example, and we specify the country as India. Okay, and if we are seeing the result of the log, now we have a new object with all of these properties. So the existing properties are coming from another person, and we created a new property, country, which is which is also available over here, right? So this is how you can spread through all of the values in an object. Suppose I just wanted to, you know uh, spread through address, right? Okay, so I can just access that object and spread whatever are the properties available over there. So you can see we have a new object, city and state were coming from address. We have spread those values and we added a new property known as country, right? So this is how you can spread through different values, right? So this is known as concatenation. There was a question in the chat whether this is the same as pushing a new value. So this would be the same as creating an empty array, right? So initially more fruits is equal to an empty array, then you're looping through all of the items in another list, all of the items in fruit, and then pushing them one by one in this more fruits, right? So you do something like more fruits dot push, first item, second item, and so on. So instead of doing all of that, you can just make use of this shortcut. You can just spread through all the values on fruits and another fruits, and you have combined array of sorts. Another way you could have done this is more fruits dot concat fruits, comma, uh, another list of fruits. This would give us the same result. uh, yeah, so this is another way by which you could have concatenated or merged two arrays, but this is how you can do it using the spread operator. All right. um, the next thing that we will be learning is arrow functions, right? So arrow functions, basically what this allows us to do is, instead of writing this function keyword like this, print name for example, or suppose I want to add two numbers, right? Some first number comma second number, like this, and then I have to write a return statement, first num plus second num. If I were to rewrite this using the arrow functions, what I can just do is I can say something like, you know, uh, sum equals, okay, it accepts two parameters, first num, comma, second num, like this, okay. and I can just say first num plus second num. So this is the shorter way of writing the same thing basically. uh, for example, and if we just, you know, if we just say sum, which is the first way, and I would just say 1 comma 2, I'm getting the result as 3. And if I say sum arrow and give the same values, I'm still getting the result as 3, right? So you can see that this is a, sort of a, shorter way of doing the same thing. We created an anonymous function over here, right, and assigned its reference to this variable. So the same thing we could have written over here, like let sum equals, get rid of the sorry, this function name like this, uh, and then we would still have access to both the functions, right? uh, so we no longer use the function keyword. Instead, we just specify the parentheses. Since we are just, instead of writing the return keyword, we can directly make use of this, this arrow syntax. And this implicitly implies that, whatever is the sum of these two numbers, return that. Okay, this is what this indicates implicitly, so we don't need to write an explicit return statement over here. So this kind of makes it a shorter way of, defining a function in ES6 and all the latest versions. But this only works in case where we have a single statement, right? Suppose I add a if condition over here, that if first num is greater than the second num, only then, add the two numbers, otherwise return, you know 0, something like this. If I want to do something like this syntax will not work. In that case, what we have to do is we have to specify opening and closing curly brackets. Then we mention all of our statements over here. So we say let result, and then we just say result equals this, and over here we can say result is equal to 0, and then we have to explicitly return the result like this. So in cases where you have a single line statement, we don't need to write an explicit return statement. But if there are more multiple statements available, we need to specify the curly brackets, otherwise we can leave that out as well, and we need to explicitly return the result of the function, right? So there's a question, what is the difference between ES6 and ES7? So ES7 had a few more new functionality. So every year, some or the other new functionality is added. So for example, in the latest versions of JavaScript, we have this new at method available. Okay. So on the array, so for example, fruits dot, at, and we give the index, for example, 0. It's giving us, whatever is the value at the 0th index. And the advantage of this is, suppose you give a negative index, right? Suppose you want the last element, you give -1 and it will give you the last element in an array. If you are interested in the second last element, you give -2, right? So kiwi was the second last fruit, right? So it's giving us that as the result. So every year, in the latest version of ECMAScript, or I think this was available probably in ES 2021. I'm not sure, either ES 2021 or ES 2022. Either one of those, this feature has been, added to JavaScript. So you can Google the difference between ES6 and ES7. There would have been a new set of features added to ES7 on top of ES6, right? So I don't remember exactly what was added, because I think currently right now we are at ES12, right? Which represents ES 2022. So now don't get confused by all of these numbers. You know, they're basically saying the same thing. Okay. Um, so that was with regards to the arrow functions. Another thing is when we use arrow functions, we do not have access to the this variable, right? Whenever we are writing, if we try to do something, if we log, do a console.log of this, when we call the sum function over here with 1 comma 2, we will get a result for this object. When we do a console.log for, let me convert this into an arrow function. Okay, and if we try to do a console dot sorry, if we call sum a, which is the arrow function version of the same thing, uh okay, this is having access to this, but in terms of so whenever we use these arrow functions, we we cannot have access to this bind functionality, right? So if I do something like sum a dot bind, and if I specify null comma 1 comma 2, okay, and let's try to log this to the console like this. Okay, so and we need to actually call this over here 1 comma 2 like this. So we are getting the result over here, but instead of this, if you remember, the bind function accepts the first parameter, which is the value for this, right? So over here we have set the value for this as null, but even then we are getting the result as window, and we're getting the value of this as uh, window, right? So you cannot change what this is pointing to inside an arrow function. Okay, so if we try to do the same thing with this sum variable, okay, and you can see that, hang on a second, we're still getting this over here. So okay, so maybe so basically what happens is, let's so what happens over here is that in arrow functions, we do not we do get access to this, but I think I was talking about the wrong thing. We do not get access to the arguments, okay, the arguments object. So if I log the arguments object like this, and if I log the arguments object over here, in case of sum, basically, right, when I'm calling sum over here, we are getting the list of arguments like this. When we are calling sum a, okay, so we are getting a reference error over here, arguments is not defined. So in case of arrow functions, we do not have access to arguments. So that is one difference. But instead over here we can make use of something known as we can make use of the rest property. So for example, others, like this. And if I call, and if I log others over here, you can see that if I specify multiple values over here, they are available in others, like this, right? So that is how you can access multiple arguments which you are passing using an arrow function. Okay, we do not have access to arguments, but we can make use of the rest property to achieve the same functionality. So that was my mistake, I was talking about this. So thanks Sumit for pointing that out. Then let's look at another thing known as optional chaining, right? So in case of optional chaining, what happens is, suppose we have another person available with us, right? So let's take a look at the another person object. Okay, suppose what we want to do is if another person, so on the person object, right, let me uncomment the person object over here. Okay, let me just paste it over here. Suppose we have two objects, person, and we have first name, for example, J, last name as D, right? And then we have a variable known as age, which is, for example, 28. And then what we want to do is if person is defined and person has a age property, right, we want to log that value in the console. We want to log person.age, right? Okay, so we can see that the value 28 has been printed. Now suppose I replace this person object with another person, right? And if I try to execute the same statement, uh, we are not getting a result because another person doesn't have the age property on it, right? So because of this check, it is not being printed. Now instead of having this check, another person and another person dot age, something like this, what we can do is we can check whether another person, we can make use of this question mark dot operator. So what this means is whatever comes before this question mark and dot, it will check whether this value is defined or not. If this value is defined, right, only then it will try and access that property. So actually let me give a much better example than this. Suppose we want to print the city, right, which is available on another person, right, because there's this address object. So what we will check is another person dot address dot city. Okay, and then we say another person dot address dot city, like this. So if this value is available, we are logging it to the console. If I replace this with you know the person object, like this, I'm getting an error, right? It's not able to read that property of undefined, right? We do not have an address object on the person object, right? So if I want to ensure that we do not get this kind of an error, we can make use of optional chaining. So we will add a question mark over here. So first it will check whether person is defined or not. Okay, so person is defined, right? Then what we want to do is we want to check if city is defined. So we will add a question mark over here, right? So it will check whether address is defined or not. So in this case, address is undefined, right? So it will not try to access the city property. Now, if I save this, we no longer get that error, right? So without optional chaining, we would have written the statement like this: if person and person dot address and person dot address dot city, right? If all of these conditions are true, only then log this value. So if we replace this with, another person, right? So we were logging the value, we were getting the value, right? But we were writing three different, such a long condition. Instead of writing all of these conditions, what we can do is we can make use of optional chaining, and we can just do question mark dot like this. It will check if another person is defined. If it is neither null or undefined, it has a truthy value. Then it will proceed to accessing this property on this object. If this is defined, then it will proceed to this part. So we are still getting the result as Pune. Now if I were to replace this with person over here, we are not getting the result in the console since address is not available, right? So instead of having that long condition, we have condensed that condition using the optional chaining property. Okay. The next thing that we will be looking at is the coalescing operator. Rather, it's known as the nullish coalescing operator. So, suppose I want to assign a default value to a variable. So, default, or rather, age, for example, equals um, person dot age. Okay. If that value is not available, we'll set the default as 20. Okay, let's log this to the console. So person dot, oh wait, let me, yeah. So over here we see that earlier what we used to do is we used to make use of this condition, right? The or operator. If this part of the expression was true, so this value would have been assigned to age, right? And if this part was false, this value would have been assigned. Okay, so for example, instead of using person.age, we say another person.age over here. Since another person does not have the age property available on it, we are getting the result as 20. Okay, so since this part of the value was uh, you know not there, this part of the expression was assigned as the result to this variable, right? But suppose we had a scenario where we wanted to where the age was available but the age was set to 0. Okay, so let me change this back to the person object and let me modify the age to 0. Okay, so what is expected is that I should have got the age as 0, right? But instead I'm getting the result as 20. That's because when we make use of the or operator, what it does is that it evaluates this condition, right? Now since 0 is a falsy value, this resulted in, even though the age object had a value assigned to it, this value was ignored, and instead the value 20 was assigned. So in one of the recent versions, the nullish coalescing operator was introduced, which is nothing but two question marks like this. What this ensures is that only if this value is null or undefined, only in that case it will, this value will be assigned, right? It will return whatever is on the right hand side of this coalescing operator. Otherwise, this value would be returned. Okay. Now, if we save this, now you can see that we're getting the result as 0. Okay. Since age is neither null or undefined, so we were able to, make use of the correct value over here. If I set this to undefined, for example, you can see once again we're getting the result as 20. And even if I set the result, the age to null, I'm getting the result as 20. So that is how the nullish coalescing operator works. Only if this results in a null or you know undefined, if the result of this expression is null or undefined, only in that case the value on the right hand side is considered. So for example, if I set this to false, right, I'm getting the result as false. But if I were to replace this with the OR operator, I would get the result as 20, right? So if you want to assign some default values and you do not want them to be, and you want to consider, things like empty strings or zero, you can make use of the nullish coalescing operator. So these are some of the latest features which are available in JavaScript. And we going ahead, we'll be making use of these functionalities which we have learned in today's session. All right. So let's end the session over here, and we'll take the doubts in the Discord voice channel. Okay. So I'll see you guys tomorrow. I hope you guys enjoyed today's session. We learned quite a lot of things. And yeah, I'll see you guys tomorrow. Okay. Take care.